All right, for these next two examples, we already have them in factored form for us. Saves us quite a bit of the work. We'll just work on dealing with the points, the multiplicities, and also talk a little bit about end behavior when we have something in this form. So we've already got the factored form, which means we already have the zeros, right? X plus 3 equaling 0 will give us a negative 3. X plus 1 equaling 0 will give us a negative 1. And x minus 2 equals 0 gives us an x of 2. So with those points, make sure again you get them in order. They happen to be in order in this case. Negative 3, negative 1, positive 2. And now, what we don't have is end behavior. And we've mentioned this before with polynomials, but as a reminder, this is not in the multiplied out form, so you can't just look at that lead term. Don't spend the time, don't waste the time multiplying all this out. We can see the lead term very quickly and very easily. You just need to look at two things. First of all, you've got these factors and their powers, right? This is the first power, and second power. If you were to multiply all these out, you would have 1 plus 1 plus 2. 1 power of x, another power of x, and 2 powers of x. That immediately tells us the degree on this polynomial is a fourth degree polynomial, guaranteed. And since these all start with just x, and there's no lead coefficient out front of this, we know that the a, we call a sub n, the lead term, is positive. Right? There would have to be a negative number out front here, or one of these x's would have to have a negative in front of it if we were going to have a negative lead term. So even degree, positive coefficient, that's going to be our, similar to our x squared function, end behavior. We're going to have rises to the left and rises to the right, end behavior. Now let's talk about these points. First of all, let's get our graph labeled. Since there's an or equal to, right, that line there, that tells us that these points will all be included. We're going to fill in those circles. They are all part of what we would want as an answer. Then we'll go back to the multiplicities, coming from one factor, and two factors. So this being multiplicity 1, meaning our graph should cross there. This coming from multiplicity 1, our graph should cross there. But this 2, again, coming from a factor of 2, multiplicity of 2, tells us it should bounce there. So crossing and bouncing, right? Crossing here, bouncing there. So here it's up top. Here it's positive. I'm going to write just a single sign now. It's positive up here. It hits that point and crosses. So it's now negative down here. It's negative down here, comes up to that point and crosses. So it's positive up here. It's positive up here, gets to this point where it bounces, bouncing from positive and staying positive. But that's also good because that positive, again, lines up with our end behavior. And so again, with a quick sketch, if you're doing this, that's what we got. We got that kind of shape to our graph. Now, with this shape, now we go to the actual inequality we want. We want to know where it will be greater than or equal to 0. So we've got the or equal to telling us that we'll fill in any endpoints or include any endpoints that are necessary. The greater than meaning the positive. Well, it's positive over here. So we'll start at negative infinity, go up to negative 3 and include it because of the or equal to. Then we're going to start here for positive, so starting at this negative 1. Starting at negative 1, now notice, it's positive here and then we get to the 2. But the 2 is included and the 2 is part of what we want. And after the 2, it's positive again. There is no reason to put a stop here at 2. If anything, we would write, we stopped at 2 and included it, and then started on the other side of 2, including it again, and that's redundant. We don't need to do that. We don't do that. We just say, the x values we can use start at negative 1. They include all of these. They include the 2 and everything right of 2. So we actually are going to take that off to positive infinity. Again, that is because all of this is part of an answer. We don't need to stop and jump over anything here, so that all became a single interval. And then that would be our answer. Moving on to example 4. Very similar approach here. We've got our 3 factors, giving us our 3 zeros of 4, 2, and negative 1. So as far as our number line is concerned, in order, -1 comes first, then a 2, then a 4. We notice that the inequality is not an or equal to, so we will just put open circles on all of those. They're not going to be a part of our answer no matter what. Back to the end behavior idea, now there's just 3 factors, 1, 1, and 1, right, all to the first. So n equals 3, and again, with x's being positive and no number out front, a to the n is positive, so a cubed, right, an odd power with a positive exponent, or positive coefficient, would have that same end behavior as our normal x cubed of falls to the left, rises to the right. So over here, falls to the left, over there, rises to the right. And so, with all of these being multiplicity 1, we know all 3 of these are going to cross. So we go from low, cross to high, cross to low, cross to high. That's it. Below to above to below to above, and that lines up with our end behavior. So there's our signs in our different intervals, and now we go to what we want as an answer. We want to know where it will be positive, where it will be above 0. Well, it'll be above 0 here, from -1 to 2, and we don't want to include them. Oops, I just wrote the wrong number. -1 to 2, from here to here. And then again, once we get to the right of 4, not including 4, off to positive infinity. That'll be the intervals where our graph or our function has positive y values.